right, thanks so much, everyone. Let's see. I want to reiterate, like, even if you're not actively looking for a job, if you're not actively looking for a position, like DataNerds is one of those great opportunities you can have just to network with other people. It's like the worst case scenario is you meet some other cool people to talk with. So very strong advocate of being involved, even if you're not actively looking for a change in your career or anything like that. So I want to start off with this talk by first off promising I'm going to keep on time. If I just skip through parts of my talk, that's totally okay. I'm going to make sure I'm not holding anyone up or going to be rude or anything like that. And I also want to frame it as like, this is a very different way for me to present my thoughts and my experiences on data science. I'm going to try something completely different. So I'm really looking forward to it. Some of it may stick, some may not. That's okay. As Glenn has said, like my topic overall is this very vague, boring kind of concept of introducing data science to a company or a team, challenges and opportunities. And as soon as I gave that title, I wasn't really super happy with it. But I don't worry, I sort of like spiced it up a little bit. So in this case, it's gonna be child's play, which is using kids' entertainment to introduce black boxes to a non-technical audience. And the reason that I really sort of came to this theme is because one of the big challenges I had as a data scientist, and I'm sure many other people here in this room and on the Zoom call have had as well, is sort of like communicating the challenges and the value of data science to someone who isn't a data scientist. I think a lot of my background was very much taught into like, okay, this is explaining data science to someone who wants to be a data scientist, and that's not always super helpful. So as I've been growing and developing in my career, I constantly think of really simple examples that even a kid can understand for what we do, why we do it, and what that means. So like everything I'm going to be talking about today is going to be like a metaphor comparison to something from my childhood. So I'm looking forward to this. Before I go into much further, I'm going to give a word of caution. Don't worry, it's nothing bad. I just want to emphasize that I am not a highly paid consultant. I'm not a leader in AI and machine learning research. I'm just some guy. So I've had these experiences. I'm hoping other people can learn from them. Maybe it's just things that I'm doing wrong, and that's okay as well. I do like to say, though, I am not easily offended if I think it would be a success of this talk. If someone, interrupted me or raised their hand or called me on Slack, it's like, I disagree, and this is why I think that is. I think that'd be fantastic. So please, by all means, like interject, ask questions. This slide deck is sort of like a way to help me organize my thoughts, because otherwise I would just, go off into tangents that had nothing to do with anything. But I just want to bear that in mind. And I know I'm going to talk about this a little at the end as well. I'm going to do a brief pitch. Please reach out to me on LinkedIn. It might take me a message or two to respond, but I do love talking to people. And if I can be just a sounding board, if you want practice an interview, if you want advice on careers, like I love talking about stuff like that. Again, I'm not something special, but sometimes that's good just an ear to listen to. All right, so now let's the meat and potatoes of the talk, right? Well, let's say this is a position a lot of people have been in. A company is looking to get data science off the ground. They want to get up and running. They hear about it in the blogs and their conferences. Everyone knows like what's machine learning and artificial intelligence is being used by Google and Netflix, and can really bring a lot of value to a company. So in order to get that off and running, normally they have to get someone who is a data scientist or someone who knows data science to come work for them. And it doesn't necessarily just have to be a small company either. One thing I've seen a lot of as well is you'll have a super big company, a pharmaceutical company of tens of thousands of employees, and they're looking to use data science in a completely new part of the company. So when they do that, they usually, again, will sort of start from the ground up. They'll acquire a data scientist, they'll bring them on board and just sort of interject them into their existing business processes, but they're sort of on their own, right? They're not part of the larger data science team. And if that happens, they're going to be in a very similar position as if you're a data scientist at a brand new company that's sort of off the ground and up and running and is rapidly expanding their footprint in the company, right? And I've also noticed that this can be the case for a lot of different kinds of people in their relative career position. You can have a brand new data scientist who's being recruited to a company to start data science. Other times they'll have a very established senior person who's been in the game for years. So this same problems, these same challenges can apply to a lot of different people. Or alternatively, maybe you're just a junior data scientist, could join a new company, you sort of want to know what's going into, right? Okay. So in this talk, I sort of like organized my thoughts in a series of steps. So basically, you go into a company, you do step 1, then step 2, 3, so on. The reality is, though, these steps are not completely distinct. Unsurprisingly, they're going to bleed into each other. You might have to jump around in real life, or you might have to repeat them over and over and over again, and that's okay. But this is a really good way for me to think about it and explain it. And pretty much every time I go to work, I'm thinking about one of these steps or another as soon as I'm talking to another stakeholder or within my team or within the company as a whole. Okay. So the first step then, now that we have all that out of the way, is when you get to a company, when you get to a team, and there's not much data science going on, they're sort of looking to you to start that up. So you have to explain what data science is and is not. And you better get comfortable with that, because you're going to be doing that probably for a very long time if you haven't already started doing that already. And I remember the first time I was actually asked this question, at least the first time I remember. So I was working with one of my former colleagues who recruited me to her company that she was working with, and she was my boss for a while. And she's like, "Hey, everyone," she came up to me and my coworkers and say, "Some of the executives are looking for, 1-2 sentence description of what a data science is. Can you help me out here?" And after about 5 minutes of thought, I sent her this picture because I really had no idea. It's just like, it was such a hard thing for me to describe, even after being in all these courses and having all the statistical knowledge and experience. I had no idea how to explain what data science was. It was just like magic to me. So that was the joke. But of course, that's not really a good answer, but sort of articulated the thought that it's kind of hard to talk about. It's kind of hard to describe what data science actually is. So then I did some more research and I started reading more blog posts, and I got a lot better answer. And I'm sure a lot of people have seen this before, right? This is a diagram I pulled from Drew Connolly's data consulting website. If you haven't seen this exact diagram, you've probably seen something very similar to it. And it's this idea that data science is a combination of a couple of different disciplines. So math and statistics is sort of one of the bases of data science. I consider it the most important thing more than anything else, but what do I know? But of course, another big part of that is what in this diagram is called hacking skills, which I sort of see as, computer programming, being a software engineer, a data developer, whatnot. And then in the bottom corner, which is in blue here, is expertise. And that's sort of like domain knowledge, right? You can imagine there's data scientists in every kind of field of research known to man, every kind of industry known to man. So maybe that is experience with healthcare or marketing or medicine or chemistry, who knows? But it's a combination of those three things. And when you get all those three in the right combination and the right proportions, you have data science. The problem I had with this is that this was a tool that was really good to explain what data science was to someone who wanted to be or was a data scientist, but it wasn't really clicking when I was trying to tell that to, the VP of sales or the human resource analyst or the academic professor in chemistry. It just didn't really make sense because there's a lot of knowledge you had to have an understanding of in order to even understand that definition. So for years, I sort of came on this quest that I wanted to find a better way for me to understand data scientists and data science that didn't require all that knowledge of statistics and programming and expertise and domain knowledge. And I wanted to do it in a way that could explain it to just about anyone, including my 8-year-old daughter or my boss at the company or the HR executive. And I had a eureka moment. Okay, so bear with me. I know this is going to sound really strange, okay? But I'm sure a lot of you remember this character, the Tin Woodman. He's from The Wizard of Oz. I'm sure a lot of people here have seen that movie. And in The Wizard of Oz, the Tin Woodman is a living person, but through magic and circumstance, his flesh and blood body was replaced with tin, with metal. So now he's a purely tin man, but he's still very much alive. In contrast, there's another character from The Wizard of Oz, and it's actually from the books. If you haven't read the books, they're great. I highly recommend it. And this character is named Tick-Tock. Now, like the Tin Woodman, Tick-Tock is entirely made of metal, but he's not alive. And the book makes that very clear, that Tick-Tock is not alive. He's not like the Tin Woodman. Tick-Tock is actually one of the earliest examples of a robot in literature, before the word robot even existed. And I read a quote about them from the story, and it was really cool. It said, "Yet Tick-Tock was popular with the people of Oz because he was so trustworthy, reliable, and true. He was sure to do exactly what he was wound up to do, at all times and in all circumstances. Perhaps it is better to be a machine that does its duty than a flesh and blood person who will not, for a dead truth is better than a lied falsehood. And this sent a lot of wheels in motion for me. I love this quote because it helped me understand the difference between business logic and data science a lot more clearly. So with these characters, again, there's sort of these similarities. They're both made of metal and they both never tire. Neither one of them have to eat or sleep at all. They never tire. But that's where the similarities end. The Tin Woodman is very emotional. It's sort of a running point in the books and the movie that he's prone to crying and he sort of hesitates, he may act unpredictably. TikTok, on the other hand, as being a robot, is completely unemotional. He can mimic emotion to a certain degree, but that lack of emotion, that lack of being actually alive is what allows him to act instantly and definitively. There's no hesitation, there's no doubt about what he's going to do if you know what kind of information you gave him in the first place. And I saw so many parallels between that and between business logic and machine learning. So again, maybe this metaphor doesn't work for you, but it clicks for me, so let's go and go with it. So like, if we can see it, the Tin Woodman is sort of the version of business logic, right? He's made of code, he never tires, but he's values-based. He's based off human intuition, human beliefs, and human emotion, because it's very, very human and flesh and blood. Machine learning and data science as a whole is very different. It's also made of code, it's also never tires, right? Both business logic and machine learning model, if you press the script, it'll run, it'll do that fine, there's no problems, provided it's coded well. And they're that similar in that way, but machine learning isn't value-based, not necessarily. It's not based off human emotion or intuition, it's based on an outcome, right? That's the whole point of modeling, is we define that outcome, and everything we do about that is meant to shape that outcome. It's meant to define the data that was related to that outcome in the best possible way. So because of that, the workings are largely divorced from human expectations and intuition. So for me, this is like a much better and natural way to understand what data science is and is not, what it can and can't do, besides all those other diagrams and textbook definitions I had. So what I want everyone here to remember is like, even if you don't like this metaphor, this comparison, you got to find a version of this for yourself that you can tell to other people, because data scientists are storytellers. So you need to find that story, either you lift it from an existing source like I did here, or make one up yourself. That makes it easy to understand what data science and machine learning can do, independent of any of this business speak and jargon about statistics and math and computer coding. Now,
Ray, I'm going to interrupt for just a second.
Please.
Well, I can't check the text very well, and I see there are some on the chat, but also in the room. I'm wondering if there are any questions or comments at this point.
Okay, open the chat. If not, that's totally okay. Again, thank you so much for interrupting. Please don't hesitate. Anyone on the Zoom call or in person, don't hesitate to interrupt me at all.
And Ray, I may do this one more time since there weren't any comments. I wonder where you say the workings are largely divorced from human expectations and intuition. There's still this possibility of bias based on the gathering of the data and things along this line. And I wonder how you differentiate between the bias that may come into the system versus the values and beliefs in some ways do come into data science based on that value.
You're 100% correct. And I was thinking about that when I put together this talk. And in fact, there's actually an example in the book from this too, is that there's a notable story and there's no notable instance where TikTok makes a mistake. He comes to the wrong conclusion. And it's made very clear the reason he did that is because he was given bad data. So that's why I try to put that qualifier of largely, and I could go into a whole spiel about bias and problems of ethics and machine learning and data science models. So you're 100% correct on that. What I want to emphasize here, though, is how like the results and the inner works in the data science are often going to be a little bit more divorced from the intuition and emotions and beliefs that are guiding human business logic. And that's a source of a lot of tension, in fact, when you're bringing data science and machine learning to a business, is because the results that the models are producing and the weight that attributes to the different data can be very different than what is commonly believed or that we feel that should be the case. But yeah, the last thing I want to do is try and paint this picture that machine learning is free from bias and error, because we all know that all the data that we're feeding that is going to be reflected in outcomes as well. But yeah, I'd love to go into that in more detail as well at some point.
Thanks, Ray. Sorry for the interruption.
No, not at all. Okay. So when I started thinking about these characters more, it really helped me understand what data science can and cannot do and what it is and is not. So my conclusion from this is that data science can use statistics and mathematical axioms to tell you how to reliably measure an outcome. And just like TikTok, it strives to be trustworthy, reliable, and true. So those are the three words I most strongly associate with what data science should be. But it cannot tell you what that outcome you should be measuring is or what cost you should spend to be there. Because again, that's the human side of things. It's just tell you, what do you value? What do you care about? What are you willing to give up to get there? Those are all the human elements that data science cannot necessarily tell you to do in a good way. At least that's not what it's intended to do. Now, because of that, data science models often sacrifice human intuition and emotional intelligence for cold, hard performance. Anyone who's worked in healthcare, who has worked with data science models and sort of talked with doctors that work with patients will know this firsthand. Usually machine learning models will come to different conclusions or put different emphasis on things than a human doctor will, and there can be a lot of conflict in that. So that can make some business stakeholders very uncomfortable, something to be aware of, but I'm not going to belabor the point too much or get into negatives here. But I wanted to sum up this up is something very on a positive note. Basically that in the story, the Tin Woodman and TikTok, they work together. They were friends to the extent that a robot and a person can be friends, and they were celebrated mutually. So I want to emphasize that a lot of times data scientists sort of like take a negative view of business logic. Understandably so, we see it as like, an inferior form, but there's a place for business logic and to work alongside with data science, and these things should be used collaboratively. So just want to end things on a positive note there. All right, so a few different points of this talk, I'm going to give a hot take. This isn't something to be super controversial, but it's something that instead it was surprising to me. Is that when I started off as a data scientist, this is not something I thought would really be as important or important at all. And I sort of realized it actually was something I should care about in a lot more detail. All right. So the first hot take is when evaluating data science and business logic models, I am more concerned with value than performance. This is going to sound kind of strange, right? Because when you're a data scientist, when you're training to be one, you really get it drilled in your head about performance metrics, F1 score, ROC AUC, precision recall. And that's what I cared about a lot earlier in my career. And in fact, sometimes I still go down rabbit holes trying to make sure my model is as performant as possible. The reality is, though, is that you got to do a trade-off between actually bringing value to the business. When you are presenting to stakeholders, when you're presenting to the executives, they're going to be far more concerned about, is this actually saving us money? Is this actually saving us time? They're not going to care about the technical performance metrics, rightfully so. That's not their area of expertise. That's not what they should be focused on. So when you are communicating with business stakeholders, you should strive that all metrics should be directly tied to cost or time. Maybe that's a little bit of an oversimplification, but at least when I talk to these individuals, I really try and drive home exactly how this is going to bring value to the business. Because again, assuming that you're working for a for-profit company, that's really why they brought you on in the first place. And this is going to cause some tension in your own work as well, because you're going to decide at what point do you stop trying to tune a model, do you stop trying to do feature engineering and sort of recognize that, hey, I got something that brings value to the table. I'm going to try and get this in production and get going with our existing business processes as soon as I can. All right, and again, when you're talking with other stakeholders, I really recommend against talking too much about precision recall, F1 scores, even p-values. Those are reserved for my internal research and development work and evaluation. If I'm talking to a non-data science, non-statistical manager or individual contributor, I really consider it a failure on my part if I start going into the weeds about this stuff, because it's just not something that should be part of their life. Okay.
All right. Before we move on, I got a question on that.
Please, please.
Thank you. So this is Nathan for those that are live in the room, but can you speak to the tension between evaluating a data science model on a value basis rather than performance?
Yes.
Compared to the idea that you can't know ahead of time what the value will be.
100%. So fortunately, you do have one advantage if you're in this situation of you're trying to bring data science to a new team or a new company. And that is your data science models, your machine learning models, or whatever data science tool you're going to bring is going to be replacing something that is either very bad or is going to be replacing something nothing at all. So it's almost a guarantee to bring some kind of value. In terms of value versus performance, what I mean is I get very tempted to try and maximize my performance metrics through endless hyperparameter tuning, through endless feature engineering, trying to make sure it's the best possible source of data. But the longer you do that, the longer I do that, the less time the model is actually going to be in production, bringing value to the company. So when I say measuring, or being more concerned about value than performance, or trying to balance value with performance, what I mean is make sure you can get a model that is reliable, trustworthy, and true, even if it's not perfect, because you want to get that into production, into a usable setting as soon as possible. And sometimes that means not using the best techniques. Maybe it means you're just going to use a logistic regression instead of the brand new out of the box neural network model. But you can spin up a logistic regression model very easily, very quickly. It doesn't take that much at all. There's going to be a lot of value to that. It's not going to have the same performance as neural network model or something like that, probably. But it's still going to bring a lot of value. And if you can do it quicker, then that's what you should really be leaning towards.
Awesome, thanks. If you don't know Lindsay Clark, she's part of our community. She gave a talk at the Nashville Analytics Summit, which would kind of maybe push back against some of those ideas. But yeah, definitely appreciate that.
Yeah, Lindsay was one of my first directors. I consider her a mentor. So she's a smart woman. So I would take that seriously. But yeah, I love talking about this kind of balance of exactly how you should balance these two together. Part of my overall arching philosophy is that I am actually a lot more interested and concerned about trying to get a working model in production within the existing ecosystem of a company's technology stack with their engineers and developers. I consider that a greater success than having like an ultra perfect model that I have to run in a Jupyter notebook or something like that. But again, it's going to be very situational. It's going to be very dependent on who you're working with. There's never going to be a very clear line to draw between value and performance. You got to decide the best for yourself. So love hearing the feedback on here, these kind of things. Thank you so much. All right. So step 2, identify the appropriate tools for your job. You got into the company, you've talked about what data science is, people are generally on board, they're excited. Now you got to figure out what you're actually going to be working with. And again, that's not really the super specifics of what modeling algorithm you're going to use. I'm talking more about this kind of stuff. Again, I'm sure a lot of us have seen this diagram or something very similar to it. And here we got, for data storage, we got MySQL and Postgres and Redshift. We can transform our data with Python and SQL again, make models of scikit-learn, visualize with Power BI and Tableau, maybe throw in a ggplot library or pandas library, and we plug it into pipeline and everything looks together really well. And this data visualization chart is really cool because it shows you all the different options, right? And it sort of like fits together like Tetris. There's a lot of different possibilities. And eventually you just got to find something that works, and there's all these different options. What I found was it didn't quite work this way. The reason behind that is because we rarely have say over all the tools available to us. And I don't think that's something that's, I acknowledged to myself a lot when I was getting started off at my last company. There's a lot of reasons for that, right? The cost. If maybe they don't want to spend the money on the Tableau and you have to use something that's already free, or they don't want to have a DBA to manage the database. But there's also just other realities involved. You have to take into account the consideration of preference of established team members. If all you know is Python, but you go into a setup where everyone comes from academia and they're all using R, they may not be super on board of using Python, right? So you're going to be a little hamstrung on what tools and techniques you actually have available to you. And of course, there's also other things like limited resources and security. You can't, I know some of the data security guys always get a little cringe when we data scientists use all these open source libraries and we just download anything that sees fit. I mean, there is some security concerns about that, let's be honest. So in reality, when we go to a company and we're making it in data science, and this is gonna be true throughout your career, you're not really playing Tetris. It's sort of like you're building a puzzle and you've brought some of the pieces and your company is providing you with other pieces, but they're not necessarily adding up to be the same picture. But you got to still find out a way to make it work, right? So in this example with the puzzle, it fits together, but you're not necessarily going to like what is finally going to be coming up in this picture. The good thing is that over time, you can sort of smooth out these wrinkles a little bit and it gets a lot more painful. I do have some recommendations there. This is stuff that I found to be pretty successful for me. Is I try to be flexible with the non-essentials, right? If they really want you to use Tableau, but you only know Power BI, is it that much of a stretch? If they want to use Redshift instead of MySQL, that's probably something you can work with. And when possible, I always like to use the tools favored by the engineers and developers I'll be working most closely with. I started off as a data scientist learning R. When I came to TechnologyAdvice, I was really excited to learn Python because I thought there was a lot of opportunities there to learn from the software engineers and software developers about doing a lot of practices I thought were very beneficial, like unit testing and type annotation and making classes and all sorts of stuff like that. And I did. I started learning all that and worked really great. And that made it a lot easier for me to get my code into production. I was able to plug in my models into their APIs and their microservices a lot more easily because we were sharing not only common programming languages, but I was able to learn a lot of the good coding practices that they were already using and make sure everything was a lot more seamless. It was a big jump from just making models in an R script or our Markdown file or even a Jupyter notebook, but I found it very advantageous. All right, so hot take number 2. This might be my hottest one yet. I think I'm really unusual in the data science community. I don't actually like Jupyter notebooks that much. I think they're okay. I stopped using them when I realized they weren't very useful for communicating with anyone who wasn't already a data scientist. Let me explain that a little bit more. Basically, a few years ago, I was doing all my reports and analysis was in a Jupyter notebook, but no one really cared about starting up my environments and then rerunning all the results, rerunning the code because they weren't data scientists. But what they did care about is the results. Okay, someone else agrees with me in the chat about the notebook, so I'm not totally alone there. That's good. They didn't care about the notebooks per se, they cared about the results. So I was making all these really sophisticated and fancy notebooks and just like copying and pasting the images and throwing it into a slide deck, which is what they really wanted. So I wouldn't be that concerned about some of your diehard tools that a lot of data scientists hold on to. Just sort of like figure out what people are responding well against and go with that. The good news is I'm not saying I'm not crapping on IDEs or data visualization, just recognize there's a lot of other alternatives out there and Jupyter notebooks come with a lot of overhead. I use PyCharm to do a lot of my data visualization. And again, I sort of just copy those graphs and make a nice slide deck, which is a lot of the business stakeholders really are drawn to. So, okay. Step 3. All right, so you know your tools. Everyone knows what a data scientist is. Okay. Oh, what do you use to deploy production scripts? That is a very good question and one I still don't do very well. I will say so I have my own Git repo that I work with the software engineers and software developers to do all my R&D work. Okay. When it comes to getting a model in production, we essentially recreate parts of that environment in their existing microservices. And so I have essentially, there's some duplicated work, right? So I have a lot of R&D work, and then I transfer all that stuff over to a more production ready environment. And then those are run using various cron jobs, schedulers, and some even other more sophisticated services that I probably can speak very poorly with. So again, I don't think it's a great solution because I'm doing double work in a way, sort of doing some R&D work and then it's being transferred over to another repo altogether, which isn't great, but it's something that my company is still growing into. It used to be that I was actually running my machine learning models from essentially my laptop, essentially. And then the results were being saved through a very ham-handed approach through CSV files and S3 scripts into their production database, but we won't go into that. But yeah, that's another topic I'd love to talk about more in detail later as well. Okay, so we explained what data science is. Everyone knows that. You know generally what tools you're going to use, like maybe PyCharm with Python environment, all that good stuff. Now you have to actually pick a project, okay? And this is really important. Your first project at a company when they're first starting data science is really, really important because you got to establish that trust and you got to establish that buy-in. Now, you may not actually have an option. They might have a project all picked up and lined out for you. That's probably not going to be super common. Usually they'll have a few ideas of what they want to do. They might have very little idea whatsoever. So you have to try and help them decide on what to do. So when that happens, you really need to pick something that is simple and meets what I think is a good number of signs that's going to be a good starter project. The first and most important thing has nothing to do with data science. It has to have buy-in from multiple high-ranking managers or executives. I consider that one of the most important things about any data science project. I can't tell you how many times I sort of try to fight the tide, and I recognize something is really valuable and it could bring a lot of success to the company. If the managers and executives don't care, it's a dead project, and it doesn't matter how good of a model it actually is, right? It could be like Minority Report or some kind of science fiction movie as how good it is. It's not going to matter if no one wants it. So make sure you have that buy-in. And ideally, it should have some kind of easy to measure outcome. I think classifiers are a really good example, especially if they're relatively balanced and it's very easy to define the categories, because it's something that everyone can instantly understand and recognize. Recommendation systems are another really good one as well, because it's one of those things that people can look at it and they'll say, oh yeah, that makes sense. And now you can do it at scale, at a level of accuracy and performance that they were never able to do before. I try to avoid rare outcome problems for the only reason that sometimes it'd be difficult to measure the return of investment on that, meaning you can have a really good machine learning model or a data science model for a rare outcome, but sometimes it's hard for the business to actually make that profitable. And again, what you're trying to do for this business, assuming it's a normal for-profit business, is show them how data science can bring them, money, revenue, save time, all that stuff. So make sure that it's very easy to articulate the value of that. Just a few other small things that I'm going to breeze through is make sure it's not anything super sophisticated data wrangling. And I try to always make sure that the model training and inference, at least when you're spinning up a Scratch script, can be run from your local environment, from whatever you normally work in. Because I know 100% that the goal of data science is to be completely plugged into the production architecture, that you can just run and train models seamlessly, and you don't have to do anything about it. I guarantee you, you're going to be put in positions where someone's going to give you like a CSV file data. And it's like, hey, can you classify this? You can run it through your model and see what happens, because we need this for our client by 4 p.m. So make sure you can actually don't have any of these huge blockers for running and developing and deploying your model. All right, so my example here is like when you're thinking about like teaching someone a card game, you start simple. You start with crazy eights, right? It may not be the funnest or most profitable thing in the world, but you can explain the rules in 30 seconds and it's been around forever, right? It has staying power. You don't do Magic the Gathering. Like, don't get me wrong, I'm a huge Magic fan. I played it for 5 years. I still don't know all the rules, right? It's super complicated. Yes, there's a time and place for that later, but start small. So when you're starting off at a company, I would say this, even if you're a junior scientist at an established company that already has a data science team, start with that small win. Make sure you get a feel for how all these processes work and all the pieces and stuff like that. Okay, I'm going to skip ahead a little bit simply so I'm respecting everyone's time. This one is really important. It's something I still struggle with to this day, but I feel like I'm getting better at it, or at least recognizing the problems therein. That recognize there's an experience gap between you and other business stakeholders. If you're a data scientist, you're coming from a very different world from the human resources executives, from the sales accountants, the bookkeepers, HR, very, very different set of experiences. And that's good, right? That's why there's defined roles for all these different people. So this is an example, right? I see this happen all the time. You're a data scientist or maybe a statistician or a business analyst, and you're given this data, right? This is the graph showing the rest, and you're asked to, draw a relationship between that data. You essentially are making a model, right? I think most data scientists would produce a model that looks something like that, right? And we all know that, okay, yeah, this is sort of like the best fit model, whatever, looking good. If you were to show a non-data scientist, non-statistician, it's like, hey, make a model for this data. This is what they're going to do, whether they know it or not. They're going to start playing connect the dots. Because they have a limited set of data, they're just going to draw lines from one to another to try and make that data fit as best as possible. They want to be as tight as it can possibly be. Now, as a data scientist, assuming you're a data scientist here or a statistician, we know that's wrong, right? Because we know if we're going to start applying new data here, that model on the left here, when we're connected dots, isn't going to fit too well because we're doing overfitting, right? It's one of the most important concepts of modeling is don't overfit your data. So why are they doing this? That actually makes perfect sense if you think about it. They're playing connect the dots, right? Something we're played with ever since we're a kid. We start off with these data points, we connect it, and we have a pretty picture, and it works fantastic. I always joke that if the data scientists play connect the dots, we're going to do this. And to us, that makes sense, but that's really hard to explain to other people why doing something like this is actually beneficial for modeling and data science and machine learning. It just doesn't click. There's that experience gap. And articulating that in a way that's easy to understand is very, very hard. So when you're collaborating with business stakeholders and you're trying to explain to them the details of your model or why we model, there are some things you really need to keep in mind. And that is, don't focus necessarily on the technical nature of the model. If you're anything like me, you love to talk about the technical nature of the model. You love talking about SHAP scores and XGBoost versus, the lasso regression and all that stuff. And it gets really fun, you get really excited, and that's okay. But that's not their job. That's not what they should be focusing on. What they should be focusing on is like how your model is bringing value to the business. So that's what you need to focus on as well, or make that clear from how that is happening from your model. Now, in order to help do that, in order to make these productive conversations, you really need to make sure all those legal, practical, and technical requirements of the project are being met. Because you're not making this model in a vacuum. There's going to be a lot of considerations. This is what the client wants. This is the data that we have to use. This is data that we can't use. Is the data going to be produced in a form that these other employees can use? You need to make sure all these considerations are being met. Because usually when people are building a model on their own, right? When the business stakeholder is playing that connect the dots and when they're making business logic-based model, that's what they're trying to do. So they're trying to make sure all these different requirements and considerations are being met. Now, you also want to make sure you're emphasizing what the value your model is bringing to the business. Don't worry about the ROC scores, F1 score, and a p-value. Focus on the value. And that can be very difficult to do sometimes, but it's very, very important as well. I also find it very helpful if you determine what process the data, this model that you're building, this project that you're going to be involved in, is going to be part of in the long run, right? So you want to talk to those individual contributors who are going to be using your model in some way, shape, and form, and make sure you're respecting all of their requirements as well. Because this experience gap works both ways. Yes, you're going to be working with people who know nothing about data science or statistics or modeling, but you as an individual are not going to know a lot about the rest of the business as well. You're not going to know what the client wants. You're not going to know what the sales process is involved. You're not even going to know some of the technology involved behind what this is all going to be plugged into. So not only be aware of how you can articulate your value, what you're doing to other people, but you really got to keep your ears open to what they want you to do as well. What are their requirements? What are they trying to accomplish? Okay, again, I'm going to skip through this really quick. So the last steps is to establish reasonable deadlines and a clear definition of success. Again, when you're on online courses, everything is a lot neater, right? Same thing with the college classroom or even boot camps, where you have, a data set, you have a due date, or if you're lucky for a class, or it's just the end of the module. That's not really going to be the case once you're in the business world. So you have to come up with some kind of way to manage that better. So I always like these silly little progress charts that we have for kids, right? It turns out these work really well for project management in technology groups as well. So there's a lot of different tools out there available to help you manage this, Jira, Confluence, a whole bunch of other stuff that I won't go into. But the most important thing is to actually write it down and define it. So when you're working with these other stakeholders, work collaboratively to craft as clear of a definition of success as possible. Now, again, that doesn't mean defining how good of a model it is. So we don't want our definition of success to be, generate a model for ROC AUC score of 0.75 on a whole data set. That's a very bad definition of success, because that's only going to apply to you as a data scientist. What you need to do is work with the business to figure out what's this mean going to be for the wider business as a whole. So a better definition of success here is reduce the customer return percentage by 25% by end of Q4. Again, purely fictional, purely made up, but you can sort of see where I'm going at with here, right? I'm showing how this model is going to be used for real-time value for the business itself. And importantly, write it down and track your progress. Even if this is only for you as an individual to keep track of, it's a very different skill to learn how to track your progress and to set realistic goals than the actual machine learning modeling itself, but it's every bit as important. Okay, I'm going to skip my demo for this last one, but I do want to bring it up very briefly before I sort of wrap this up and come to a close. Is that recognize that real world data is very messy. So I'm just going to go through this scenario really quick. I'm not actually going to do the demo again. Well, let's say you're hired as a first data scientist at a trendy upscale specialty paint store, right? Okay, so you're looking to launch a new product based on one of three colors, red, green, or blue. I know it's a ridiculous example, but just hear me out. Okay, so the company wants you to make an image classifier that can automatically determine a color that the customers are taking pictures of, all right? And they're also very firm. This new product, it's only gonna be focused on red, green, or blue, right? So how are you gonna do this? How are you gonna make it this classifier? And if you're like me, you're gonna think, oh, okay, that's easy. The business, we're gonna use a data set from the business using these images of red, green, and blue colors submitted by the customers, and we're gonna build a supervised machine learning model that's gonna predict if the classifier is red, green, or blue. That's the only thing they care about. But you have to really take in mind all the other considerations that are going to be going on as well. There might be something different colors. Are there other legal and technical requirements that the business is going to place on you? So it's not just a matter of building this model. It's a matter of taking into account of how is this going to profit the business and where all these other requirements and expectations are going to be part of you aside from just the model itself. All right. So I'm going to skip through this because we're getting pretty close to time, and I'm just going to summarize all my steps together. So again, these are steps that aren't going to necessarily be sequential. You're going to be coming to them over and over again, and they're going to bleed into each other. But you want to try and make sure you're hitting them all. You want to make sure that it's clear to all the business what data science is and is not, with your team, with the managers, product managers, everyone. You want to identify what tools you're going to be using at your job, not necessarily what model or algorithm, but like what data you have access to, what IDEs you're going to use, that kind of thing. You want to try and pick a simple project with an immediately measurable impact. Recognize that there's going to be differences in experience and knowledge between you and the stakeholders. You want to establish reasonable deadlines and have a clear definition of success for what your project is actually going to do, and recognize that the real world data is messy and it's nothing like a casual competition. All right, so I got a few minutes left, so I just want to say, feel free to reach out to me on LinkedIn. Again, I'm not the smartest guy in the world, but if you just want someone to bounce ideas off of, or get some insight, or meet other members of the community, I love talking. So don't hesitate at all. If you're looking for someone who actually does know a lot more about data science, I recognize these two individuals: Jason Brownlee of Machine Learning Mastery, there's his website, and Bojan Tungaz. He's a Kaggle Grandmaster, super smart guys. I'm really in line with a lot of their philosophy. And finally, I have my custom logo designed by one of my friends, so I'm going to plug her really quick if anyone's interested in that kind of stuff. It's just fun. It's not necessary for your career or anything like that, but I really liked it. So I'm going to try and stop there really quick and take any questions, facilitate any conversation. You disagree, fantastic. I'm loving it. But I'm just going to take a breath there so I can drink some water. And thanks so much for listening to me, everyone.
Great.
All right.
Thanks, Ray. Are there questions? Let's start on Zoom. Are there questions from Zoom?
This is Betty Ann. I have a couple of comments.
Please.
So Ray, I just got to say this was a great talk. It was really wonderful.
Thank you.
The comments that I wanted to make, I think you made these comments, but I wanted to kind of consolidate them to be sure that people really got your point. And one of them is when you were talking about, I think it was step 2 about how to pick a project. I think, yeah.
Let's see if we can jump back to that.
I think one thing to really recognize is, yeah, I'll wait for you to get there because it's easier to.
Is it step? I think it was step 3. There you go.
Oh, okay, step 3, sorry. So not only is it important to get buy-in from multiple high-ranking managers or execs, one of the problems that we had a lot was people were extremely enthusiastic, and then we would like do this project and we'd say, okay, now we've got this in place, and they're like, yeah, thanks, I've kind of moved on, or they don't know how to use it, or they're no longer interested in it, or more importantly, they had no ability really to use the results.
Mm-hmm.
So what we started to do was, and this was when I was at HCA, what we started to do was before we took on a project, even when it came to trying to introduce data science to someone or a group, we would say, all right, you need to tell me what is the data that you really want me to work with. And when I give you results, what are you going to do with it? Like, what do you want the results to look like so that you can ingest it or use it? Do you want a spreadsheet? We'll do that. but you have to demonstrate how you're going to use these results, because we did this over and over and over again. We'd come up with a model, we'd give it back to the person who asked for it, and then they did nothing with it because they didn't know what to do. They didn't have an avenue. So that was really demoralizing.
Yeah.
The other thing I'll mention, and again, you talk about little data wrangling. We've actually been asked to work on projects where like the data didn't exist. It existed in their head, but it like literally didn't exist. And one laughable, and I mean that in every sense of the word, laughable project we were asked to do was for HR. And then they told us, but you can't access the data because, you know, it's sensitive. And we were like, okay, well, then we can't build you a model. You know, I mean, it was really that laughable.
Yeah.
And then the last thing I want to say is I think Jason Brownlee is fantastic. I look for his blog posts all the time. So,
Oh yeah.
So we've got a lot in common, Ray.
Anytime I'm doing something new or just refreshing myself, I always end up in machine learning mastery. It's really helpful.
Yeah. And I'm the one who does not like notebooks.
We have something in common there.
Yeah. So nice talk, Ray. Thank you.
Thank you.
Anyone in the room? Questions? Yes, Lydia.
You read the very solid presentation. So do you mind go back to that slide where you said the messy data with the blue, red, and green?
Can you hear Ray?
A little bit. I thought I heard something about going back to the slide with the messy data.
Yeah.
Right, with red, blue, and green.
Red, blue, and green.
But for the end, I suppose, right?
Yeah.
The last example.
We cannot go back to that slide. Okay, my question is, so you mentioned the company wanting to measure which color they want, but okay, then you create a model and you say, okay, blue color is what the client would like. That's what your model said. But then if they really push out that product and find out, oh, the result is terrible. So like, how do you manage that? The result and then not meeting probably the, I don't know.
So when your model doesn't meet expectations, how do you, yes, what's your next move? Right?
Okay, so just to summarize the question, is like, what do you do when your model doesn't match what the business was expecting? Is that sort of what they were getting at?
Or it's actually inaccurate, I think is what she's saying, that it doesn't
follow the plan. Okay, we'll push out the red based on the model, but then it turns out when you push it out, it doesn't meet the expectation. And how do you manage that push out?
That's a good question. So managing expectations is really important. I'm not the best person at doing that just yet. I've been learning a lot along the way. What I will say has helped tremendously is working with the people who will be using the product on the ground, like the individual contributors, not just the managers who will actually be using this model. So in this fictional scenario, trying to work with the actual customers who would be trying to use this in reality would be very helpful to see how they're actually going to be using it. In terms of like understanding like what kind of results it's going to be producing, this scenario is a really good example of like the executives are very determined that, oh yeah, it's only going to be red, green, or blue. The users are trying to be submitting stuff that is like yellow, orange, or white and black, and be able to think about that stuff in advance, if at all possible. Like what kind of data is this model actually going to be exposed to? What kind of results is going to be produced when it's thrown those side balls, those curve balls, excuse me. I don't feel like I've addressed your question very well though. I might have to meet up with you after the fact though, just so I can gather and organize my thoughts a little bit there though. But hopefully I've started the conversation in the right direction.
Yeah, sure. Thank you. Yeah, if you don't mind.
Of course, yeah. Reach out to me on LinkedIn because I think I can answer that question at a better job. I couldn't hear you too well. I want to be able to clean up my thoughts a little bit better for that.
Thank you.
Questions in the room? Anyone? On Zoom? It sounds like you've met expectations, Ray. You've satisfied everybody's questions. So
Very good.
let's thank Ray one more time. And thank you all on Zoom for joining us. And we'll hope to see you at our next meetings of various types. So